Hello everyone, Anushya here, Senior Digital Marketer at Econ Systems, your host for today. Welcome to our webinar, Unleashing the Power of Ethernet Cameras in New Age AI Applications. To lead us through today's session, we have with us Mr. Sreeram, Application Engineer at Econ Systems. With his experience in helping customers integrate advanced camera solutions, he'll be taking us through the key benefits and possibilities of Ethernet cameras. Also, please feel free to drop your questions for the live Q&A in the chat section. We'd like to hear from you. Over to you, Sreeram.
Thank you, Anisha. Today, I'm going to talk about how Ethernet cameras solve key challenges in embedded vision and also how they make deployment, integration, and management much easier across real-world applications. Before we dive in, let's have a quick introduction about Econ Systems. See what type of solutions we are providing for last 2 decades. Econ Systems has been designing, developing and manufacturing OEM cameras. Today we have a dedicated team of more than 650 plus employees and 250 plus core engineers focused on building an innovative vision solution. Our cameras are integrated into 350 plus customer products worldwide across the United States, Europe, Japan, Korea and other regions, which serves these cameras in industries like autonomous vehicles, smart cities, medical and life sciences, and retail and more. All the products are backed by world-class quality and manufacturing teams to the highest production standards, meeting global compliance requirements. We also built a strong partnership with dedicated sensor makers and ISP vendors, allowing us to deliver the complete, reliable and cutting-edge camera solutions. With this background, let's kickstart our discussion. Before jumping it, I will set the agenda first. In today's session, we will start with common challenges in embedded vision. Then we will look the architecture of Ethernet camera and see why they are easy to use and manage. After that, we will explore how standard Ethernet is helping embedded vision to move forward. We will also go through some real-world case studies and dive into Ethernet performance with the NVIDIA Thor integration. And finally, we can wrap up with the live Q&A session. Let's see what are the common challenges in embedded vision with other interfaces. From our experience, we see the vision technology is not just an add-on. It has becoming a backbone of many intelligent systems. If we consider an industries such as intelligent transportation systems, mobility, smart surveillance, or industrial automation, where vision system plays a critical role as a first point of contact for capturing the right data that drives the entire application. But there is a challenge: capturing the right data at the right time. Delivers quickly onto the processing unit. It depends heavily on the interface what you choose. The wrong interface can limit the range, reduce bandwidth, or complicate integration. The right one, on the other hand, can unlock the powerful capabilities, simplify the deployment, and scale effortlessly. These are the few interfaces in embedded vision. Let me start with one of the common interface, which is MIPI CSI2. If we going to design in a box of the camera, the MIPI CSI2 is one of the common interface, where you can transfer the high bandwidth data, but the limitations comes in the range. It can extend the range up to 30 centimeter. Okay. And second is an USB. USB is one of the common interface. It's easy to use and it's a plug and playable device, but the limitation comes with transferring the high bandwidth data and the range. Other than that, GMSL and FED link is one of the best interfaces in embedded vision applications, but it can able to transfer the high bandwidth data and extend in the range of 15 meters. But if an application requires data to be transferred more than 15 meters, the GMSL and FED link is also limitations here. Another challenge across embedded vision systems is an host integration. Interfaces like MIPI CSI2, GMSL or a FED link require a custom driver or a firmware development to communicate effectively with the host platform, and it adds some complexity with time and a design cycle. This is where the Ethernet camera make a real difference by providing a reliable solution through this interface. Exactly, you can see year on year more users choosing a gigabit Ethernet as their primary camera interface. It has becoming the one common standard interface that's shaping the future of embedded vision applications. Before going into more detail, let's have an quick idea about how the architecture of Ethernet camera is designed. I hope most of them know that what are the active components in the camera. Let's look Ethernet camera how works both inside and over the network. First, the image sensor that captures the light and converts into raw image data, and the data that goes to the image signal processor for further processing, where demosaicing, debayering, HDR processing, and other image enhancement takes place, which produces the post-processed output. Next, the post-processed output that transfer to the video encloder block of the ISP, where the compression happens in different formats like H.264, 265 or MJPEG. This compression can reduce the file size without sacrificing the image quality. It helps to transfer the data over the network. After the gigabit Ethernet interface takes the compressed data and compressed into small packets. Each packet contains information such as timing and sequence. It means receiving in whether it is an AI server or a cloud application can reassemble the packets based on the video data or image data in order. This transfer happen the common interfaces like UDP, TCP or RTSP and more different interfaces. Also, the most of the cameras follows the common standards, allowing them easy to integrate with different platforms. Let's see the reason behind why Ethernet cameras are easy to deploy and manage. See, Ethernet cameras are deliver the flexibility of embedded vision systems due to their support of power over Ethernet technology. PoE allows both power and data transmitted over a single cable, so it can simplify the installation, it can reduce the cabling and enables a long distance data transfer. Most of the cameras follows 802 AF PoE standard, which can supply 15.4 watts of power. It's most enough for embedded vision cameras without an additional external power or power requirement. For higher power needs, we can use the PoE plus, which can supply 30 watt of power, which is ideal for the PDZ cameras. Even all the Ethernet cameras are follow the one of the common standard is an on-whip standard for seamless integration with a variety of systems. This includes NVIDIA's DMS platforms, home-based systems, or x86. Without any custom driver or extensive development effort, with the on-wave standard, these cameras can be connected easily. So it makes multiple cameras setups far easier to deploy and manage. Even when the cameras are connected to the network, the camera is assigned with an IP via static or a DHCP, enabling a direct communication with servers, VMS platforms, or a cloud systems. To take this step further, Econ Systems offer a cloud-based platform called Clovis Central. Clovis is a nothing but cloud plus vision platform used for cloud-based device management system purpose for building the vision systems. With Clovis Central, these Ethernet cameras can be remotely monitored, configured, updated, and troubleshoot in real time from pushing firmware or AI models over the air. This ensures via HTTP or HTTPS for secure authentication. Clovis Central eliminates the need of physical intervention. Also, let's talk about the cables what we are using in the Ethernet cameras. Ethernet cameras uses the shielded or unshielded cables. Depending upon the type and speed, we can choose the right cables. So for most of the embedded vision Ethernet cameras follows the shielded Cat5e or Cat6e cables are recommended. This supports 1 gigabit speed, which can reduce electromagnetic interference for a stable and high quality signal. Other key advantage we see in the Ethernet interface is an PTP synchronization. In many embedded vision applications, multiple cameras and devices need to be precisely synchronized to be work together. This is where the precision time protocol is defined by the standard called IEEE 1588 standard plays a crucial role there. This standard describes the hierarchical master-slave concept for distributing the accurate clock signals across the network. In this system, one device acts as a master clock and providing the timing reference,